No. For lines. The first section. There were 2 highlighted boxes. Go find the yellow boxes, remember? Yellow boxes. They've been important the whole chapter long. 10.1. M equals, slope equals tangent of theta. Good, that's one formula. Josh Keck, we have a test on Wednesday, so focus. Okay, so 10.1, lines. M equals tangent of theta. Slope equals tangent of theta. Remember the name for that theta? Angle of... Oh, they did it right now. Hero. Oh, that's fine. Angle of inclination. Good, got it. Okay, and then there was the angle between formula. Do you guys have both those formulas highlighted from 10.1? Okay, M equals tangent of theta. Where are your notes, Leo? Got a test. 10.1. Okay, 10.2. What was our conic section? We introduced them all, the basics and the degenerates. Yeah, circle, ellipse, parabola, but which one was 10.2 parabolas? Good. Jaden's already reading the yellow box. We have x minus h quantity squared equals 4p y minus k. Now hold on. If the x part is being squared, is that an up, down, or a right, left? Good. If the x is being squared, it's an up, down. How do you know up versus down? Vertex can be the same, I guess, right? Maybe. If they give us the focus or directrix clue, the focus is always inside. The directrix is always outside, whether it's right, left, up, down, inside versus outside. How far away is the focus and the directrix from the vertex for parabolas? P. P distance away, right? You have to take the 4p, set it equal to the constant, solve. And then the constant needs to be negative if the parabola is facing down or left. Good. And the parabola, the constant needs to be positive if up or right. Good. Okay, section 10.3. Wait. Wasn't there one more formula for parabolas? No, focus, directrix. No. Okay, sorry. Ellipses. 10.3. Yellow box. Ellipses. Do we really have to worry about who's first, per se? No, who's always first for ellipses? Always the x minus h over something squared plus y minus k over something squared. But sometimes this guy might have the bigger number, and sometimes this guy might have the bigger number. What's going on with the denominators of ellipses, the a squareds and the b squareds? What are they measuring? Major radius and the minor radius. How do you know which one's the major radius? So you find the bigger number, you look up and say, hey, does that go along the x's horizontally or along the y's vertically, right? So then you could go from your center. It depends. When you figure out your major minor radii, you look at your a and your b, and if it's under the x, you're going to go to the right that distance, to the left that distance. Underneath the y, you're going to go up that distance, down that distance, right? So A gets to the, what are the points called on the ends of the major axis? The vertices. So we get to the vertices by either adding to the h, subtracting from the h, or adding to the k, subtracting from the k. How do we get to the foci of the ellipse? Where are those guys? Let's say it's a vertically oriented. The bigger number is underneath the y. We can go the a up and the a down, adding, subtracting from k. Good. C squared equals a squared minus b squared. How can we remember minus? Because they need to be inside. Inside. So we're going to add c to the k and subtract c from the k. So the foci are inside. The vertices are on the outside, or the outer edge of the major axis. What's that one little random formula that showed up at the very end of the ellipse section? Eccentricity. Remember the formula? C over A. E equals C over A. So A comes out of the formula, B comes out of the formula, C has its own special formula, and eccentricity is just a random ratio that stands for the ovalness. The ellipticity, how do you say? I don't know. The circularness or lack thereof. Anyway, eccentricity then only goes with what conic? Eccentricity can only go with what conic if it's about the ovalness. Yeah, ellipses, right? Okay. He's trying so hard not to laugh. Kind of like Drew with the gate on Thursday. Anyway, was anybody at the Thursdays with Drew in the gate? It was hilarious. So funny. Did he keep doing the gate? Did he keep the straight face the rest of the time?
On Saturday, he bowed with the gate after the surgery.
It was so funny with the gate. He tried so hard on Thursdays. And then he just like ran away. So funny. It's awesome. Coming back. But the rest of the performances went well?
Yeah.
They did? Okay. I figured like the more you get into and just like relaxing and then the crowd. Good. It always work out the kinks. It's okay. That's why teachers come. Like, we support you no matter what. We love it. Okay. We need to go 10-4. 10-4. 10-4. 10-4. Never mind. 10-4. Okay, coming back. What's the last conic section? Hyperbolas. Not hyperbole. Hyperbolas. Hyperbolas. What do they look like?
They're like they're divorced.
They're
That's not very Christian.
Christian, non-Christian. Divorce shows brokenness. Brokenness is the reason for the gospel. So, anyway, okay, they're out. Okay, church is full of broken people.
Oh, okay.
Right? It's a hospital. It's not a opposite of hospital. Social club. I don't know. Anyway, so here we go. Where are my foci?
On the outside.
On the outside. So what's my c squared formula?
C squared equals A squared plus B squared.
A squared plus b squared. Hold on. Standard form, yellow box. You guys there? 10.4 yellow box. Is the order important as to who comes first? Yes, because of the minus. Okay, so the one that comes first establishes which axis? Yeah, but what's the name for hyperbolas? Transverse, right? Transcontinental railroad. So, transverse axis, so we start at the center, and which one comes first? Either it's y minus k over a squared or x minus h over a squared. Whoever comes first, that's the direction we move for the vertices, for the foci, and for the we'll do the asymptotes soon. So for the transverse axis, so if the y comes first, which one is it? If the y comes first, you're going to move vertical. Good, vertically. If the x minus h comes first, look at the standard forms if that helps. If the x minus h comes first, how are we moving? Horizontally. Good. And what's the c squared formula one more time? So you move a's for the vertices, you move c's for the foci. How did the b's show up? Look in that yellow box. Where is there a b besides the standard forms? Not in the vertices, not in the foci, not in the center. It's like the minor, and we need to move it for the asymptotes. Where do the asymptotes come from or start from? The center. So don't we move from the center? Let's say x minus h came first, which means it's which one again?
Horizontal.
Good. Okay, so we have this kind of hyperbola. Look up here, my visual ones. We have this kind of hyperbola, okay? From the center, we're adding a to what? H or k, if it's this way?
H.
X needs to, right? X needs to change. So if x is first, then my h is going to add and subtract a. My h is going to add and subtract c for, wait, who's c away from the center?
That's
Foci. And for my asymptotes, back to the center again. For my asymptotes, back to the center again. I'm going to look underneath the x. If x comes first, what's the letter that's underneath a? If x comes first, x goes with a, and y then goes with. So which one would I need to do first if I was rising first? Would I rise b or would I rise a? If you're looking at the standard form, b is under the y's. So yes, I would rise b and I would run. There's an asymptote. Wait, but I need two. Rise b, run a. How do we get the other one? Rise b, go backwards a, right? So you're going to do plus or minus. So the positive goes up and to the right, and then the negative goes up and to the, there are my asymptotes. And what was the point of the asymptotes again? Yeah, and it shows us how wide or how narrow, because you can't touch it, so then you have to go skim it for the branches, right?
Yes.
Cool. What does that bring us up to? 12.3. Remind me, what is it 12.3? It should be 10.5. Different book, different book, different book. So, speaking of different book, just in case you were absent on Friday, where am I right now?
You're in the Google Drive.
Yep, the shared folder. I'm in handouts, and I have the homework handout pulled up. What are you going to have to use in order to do homework?
The other one.
This one, right? You have to pull it up, take a picture of it, etc. Oh, take a picture. You want to take a picture of it? If you want to take a picture of it and not have to pull it up on your Google Drive, you definitely can. Let me go ahead and try to make it full screen. Not that you have to, but you can. That's page 1. I can turn off both lights. I think the lights off are worse, right? Isn't it worse? Oh, it's better? For the picture, it's better? Oh. Okay. Okay. Now, pause, kiddos, real quick. I had the homework page open a second ago, right?
Yes.
Hold on, check it. I am going to do the following. I know. Life is exciting. Oh, how do I strike out? There we go. Okay, 11 and 13 we're skipping. Okay, 11 and 13 is called inscribed figures. We're skipping. Don't even stress about it. Don't even worry about it. Don't even try it. But 1, 4, 5, 7, and 10 we are doing. Okay? So hold on. On the handout, was 11 and 13 copied? Or I should say circled? Yeah, 11 was circled and 13 was circled. But are we doing those? No. So check it. We're skipping the word problems. Sound good? Okay. So we need to learn how to do 1, 4, 5, 7, and 10. Remember, the odds are at the end of the book section I have scanned in there. The odds, if you want to see them as far as the odd answers are right there. Okay. So coming back, let's go ahead and finish our notes. Section 12.3, if I can get out of here. Something gets out of here. There we go. Let me get out of there. All right. Here we go, kiddos. Section 12.3a, the final section. The final frontier, not quite, but we're close. Here we go. We have 2 skip the blank parts that we did not get to fill in on Friday. One of them was the surface region, and one of them was the solid region. I just want you guys to write the following words next to these. You're not going to have to stress a lot about them, but surface region, I want you guys to think surface area. Like the outer shell. The outer shell of a figure. Think a can, just not the stuff in the can. The outer shell. I'm writing outer can. Oh my goodness. Outer shell of a 3-dimensional figure. Solid region, I want you to think volume. So the can with the inside. Okay, surface region would just be like the outer shell, like a can, a soup can, with nothing inside, just empty. The solid region would be like the volume. That would be the can with everything filled in. So I think I drew the solid region on Friday. Do you guys agree? Because I kind of connected, and it looks like it's all the way through, right? If I hadn't put these lines, maybe it could have just been the outer shell. Nick, go ahead. Okay, go ahead. You just wanted to run. Oh my goodness. It's part of his character. Okay, so anyway, here we go. What did I do on Friday, just in case someone was gone, because a couple people were. There was a z-axis because I took the xy, right? I took what was on, technically this should be a solid line, and I just messed it all up. Dotted line should be in the back, because dotted line is something that's there, but you can't necessarily see. It's all about perspective. Okay, so we have the x, we have the y, and then we have the z. So I took the two-dimensional parabola and I spun it. And as I spun it, what was formed? Kind of like a bowl, right? But technically what we call that snazzy bowl? Paraboloid. What did I rotate? Pause. What's so special about the y-axis, and why did I rotate about it? For that parabola, what was the y-axis? It's not transverse, it's not major, but what's it called? For parabolas, the axis of symmetry. Yeah, the axis of symmetry. So, for this one, the axis of symmetry was the y-axis. Doesn't mean that we couldn't have spun it around the x, but for a paraboloid, you always spin the parabola around the axis of symmetry. So kiddos, if I had had a parabola that was a different orientation, maybe it was like a horizontal orientation, not a vertical orientation, what would I have spun this one around? A vertical line or a horizontal line?
Horizontal.
Yeah. And how did I show the spin on Friday? The rotation arrow. Pause. On your test, you are going to be sketching these. I will give you a point for putting the rotation arrow around the correct place when I tell you to spin or to rotate. I will give you a point, meaning I'll take away a point if I don't see the rotation arrow. That is your way of showing me, oh, axis of symmetry, there he is, before you ever do the figure. So I'll give you a point for identifying the correct axis, and then I'll give you points for correctly showing the shape. Now, some of you are like, I don't think I could do that original one. That was a little too snazzy, even though it's not that snazzy. Some of your classmates could do better. Just remember, it's a smart board. He made it. My non-artistic ones, ready? Ready? There you go. Done. Dun, 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 dun. Do you want to try and do something a little bit snazzier? Sure, you can try to make it just like colored in and be like, oh, it looks prettier. Anyway, today I'm going to try and show artistic-ish versions just to get you artists going. You don't need a lot of encouragement. You'll be fine. And then I'll show non-artistic versions. There we go. So paraboloids, spinning around axes of symmetry. Michael?
Does it matter if it's clockwise or counterclockwise?
No. I'll take it either way. Probably if you're left-handed or right-handed, one would be more comfortable. We did not do ellipsoids. Let me give you a second to set it up. What you want to do, is set this up and show the exact same ellipse. Show the exact same ellipse on both of the axes. So I'm going to go ahead and get an ellipse going. Now, kiddos, in your homework, it's going to give you an actual equation for these conic sections. So you're going to have to do 10-4 skills of taking an equation, and I'll show it to you in the homework, taking an equation and getting the two-dimensional representation, aka sketching the ellipse, sketching the parabola, sketching the hyperbola. So in the homework, you're going to have to sketch a very particular one. I am sketching a general one just that we're going to start with. Nice thing is on the test, I sketch the ellipse, the parabola, the hyperbola for you. And I say, take this one. I don't even make you do two problems in one. I say, take this one and spin it. In homework, you're going to have to practice making the particular ellipse, hyperbola, parabola they ask for. Oh, you're going to have to review 10-1 to 10-4. Then you're going to spin. But on the test, I will give you, like we do in class, I will give you a base shape to work with. I would have you graphing a hyperbola, an ellipse, a parabola in a separate problem all on its own. Does that make sense? That way, if you mess up the basic one, you won't mess up the spin. Okay, I'm going to do an ellipse just for sake of argument, because that's horizontal. Ugh, that was nasty. I'm going to do an ellipse with horizontal major axis. I have my ellipse. I'm going to try and do the same ellipse down below. Okay, so we have an ellipse. Major axis is horizontal, right?
Yeah.
Yeah, yeah. We have two different types of ellipsoids because we can rotate ellipses around two different special axes. Parabolas really only have the axis of symmetry that's special. But hyperbolas, Nope, we're not in hyperbolas. Ellipses have two different axes, major and minor. So check out the prolate. Prolate are supposed to go around what axis? Major. Prolate supposed to go around the major axis. That was supposed to be bold. Don't know why it's not. It's still not bold. There we go. Prolate supposed to go around the major axis. You can think oblate like obtuse, or oblate, probably the better way of saying it. But oblate like obtuse goes around the minor axis. So kiddos, help. If I said I give you points for identifying the correct axis with a rotation arrow for prolate, am I going around the horizontal or around the vertical axis?
Horizontal.
Good.
Nice.
Because major is the longer one, right? Now just a few of you might want to visualize. There's an ellipse on a stick, on a string, on some sort of pulled taut figure, and you start spinning it. I was thinking football, which is nice because pro sports, you could go that way. Prolate, pro football, you could do that. You could do that. Pro football if you want. Now, some of you might want to K-pop. How did we get there? Anyway. Oh, K-pop. There's a K-pop, and I'm like, that's random. Okay, so if you want, you can show the spin. You can show it a few different places. That's totally fine. Okay? You could think of football. You could think of pill. You could think of Larry, the cucumber. VeggieTales? No one? You guys, such party poopers. Okay, but the long story short, some of you artistic ones might want to do what I did in the last one with the parabola, careful, and show like the actual twist, the actual, what would that be, the YZ parabola. You might want to show that on this one. Please don't, and I'll show you why a little bit later. Please only show your rotation using circles that are the same direction as the rotation arrow. And I'll show you why in just a second. I know some of you would want to show like, oh, hey, it flips and it's going to be all nice and pretty like this, and please don't do that. The rest of you guys are just following me anyway. Oh, my non-artistic ones, ready? Hold on, let's pretend it was this kind, okay? Let's pretend this was this kind, so the major axis is vertical, right? Okay, my non-artistic ones. You have the parabola, ready? Yay! Okay, good enough. But pause. Pause. You should have probably shown me, right? You don't want to lose that point, the rotation arrow. But anyway, if it was oriented the other direction, you would just go around the other axis because the major one would be vertical now. And just show me a spin. See how you just show a circle and it makes it all nice and pretty? Could you kind of do like some fun in showing the spin? Yeah, you could have some fun showing the spin. No, not right now. Coming back. Oblate, if you want to think obtuse angle. Oh, better way of saying it. Okay, on this one, it's harder to think about. It's harder to think about. On this one, if my hand was right here, if this was an actual and someone started spinning and my hand's right here, am I going to get hit? No, I'll be fine. On this one, will I get hit? Yes. Because your rotation arrow is going to be going around the minor, which is this guy. I want you to think fan blade. I want you to think fan blade. Because if you spin, isn't this going to have to whoop, right? And then it's going to go around and around and around and around and around. Okay? So now you do have a z-axis. I didn't want to show the z on that just because you'll see why in a second. This is going to come out. You could come this way if you want. Probably should be going. You can keep going with it. And then you can start showing your rotation arrow.
Exceeded the 5th generation.
Think cheese wheel. Think flat pillow on your mom's couch, maybe grandma's chair. Think fan blade. Fan blade, like if you were to pull it up, one of those ones you go, one of the pinwheels. Pinwheel. Think rotating fan. You guys know what I'm talking about? You live in California, although you all have air conditioning, but besides that, any of those ones that, right? Think one of those with the fans, right? Just put it up on its end. Worst comes to worst, think, what are they called? Baby bells? The little cheese wheels? The little red ones? No baby bells? Anyway, never mind. Forget the cheese wheels. Okay, my non-artistic ones. That wasn't my best one ever, but that's okay. Good enough. My non-artistic ones. Let's say that we had this same orientation. Okay? Vertically oriented. Oh! I would have lost a point.
You didn't put this argument in.
Oh, I did. He's hidden. I did. He got hidden. Just in case, so that you guys don't judge. Okay. My non-artistic ones. Let me do a different orientation. We'll come back kind of the one that's vertically oriented. You'd be rotating about. All right, listen. Listen. My non-artistic ones, you really want to listen for this. Because you're like, say what? Okay. Ready? This should have been a little bit shorter. I apologize. Ready? Non-artistic ones. Is this a pro football? No. Should I be showing? No. Because it's. So then what are you going to do? Yay! Go team! Okay? So you just like, whoop, and have it go the other way. Be like, yay! Or whoop, have it go the other way. Yay! These are not that. I know. Okay? These are very different from each other. So all you have to do is do two like intersecting ellipses and then just draw a big old like whoop around it. Okay? Non-artistic ones, do we have a way of doing it? Now here's the dilemma. Ready? Let me show you something real quick. I want to show you from of the handout, from the book itself, okay? From the odds, answers to the handout, from the book itself. Oh, look, they have all these pretty ones, like computer generated. Anyway, coming back. Can you guys look at number 3 real quick? Is it oblate? Or is it prolate?
No, it's prolate.
Hold on. Eyes up here or else you're going to not get my point. I've shown you how to draw these. And I'm very serious with how to draw them. Because as you guys look at this, number 3, is it prolate? Here's the bad thing. If you look at it real quick, sure looks like the prolate one. And some people would draw the prolate one like this, because they're like, oh, it's easy, right? Like, boop, and then it's like, yeah, just draw, boop, 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 boop. Here's the problem. Take a fan, right? The rotating fan, where the blade's going, and then face it this way. If you look straight on, what do you see? Only this part. This is technically looking straight on. It's technically oblate. Now pause. Could I tell what you mean if you draw that? No. I don't think so. I would think that you mean prolate, but the problem is you're not showing the prolate arrow, which is why I'm saying don't draw either one like this. This is awful. Tilt the axis. Put the Z going this way, that way. You have this. Show prolate. Right? This way? Prolate? No, hold on, wait. Oh, you had to go out. Okay, so you have to be a little careful, my non-artistic ones. A little careful, okay? Prolate. Make sure it goes in. Be like, yay, I'm done. Is that obviously prolate? Yeah, it's obviously prolate. Couldn't be anything else. My oblate one. What are you going to do? Have like an atom. Ready? Yay! And then, yay! Done. Okay? These are obviously different because they are two very different figures. That one's super confusing. So we're not drawing it that way, even though that's how the computer-generated one did it. Are we all tracking? So little burp, and then this one, just have it intersect, make a big hole, and then be like bleh, oblate. Are we okay?
Yeah.
Wait. Where should my rotation arrow? This one was going around this guy. Where should my rotation arrow be for this guy?
Yep, there you go.
Are we good? Okay. Done. Okay. I wanted to make sure you guys noticed, just if you looked at this, you might have been confused, but I wanted to show you why I tell you very particularly how to draw these, because otherwise it's horrible for me to grade. I'm like, let's me imagine what they were thinking. No, do it the right way. Okay, what are we missing? We did paraboloids. We did ellipsoids. Hyperboloids. You guys get to choose, because I can do either way. Do you want them to be horizontally oriented, horizontal transverse, or vertically oriented, vertical transverse? So I need you guys to draw this, write this with two as identical as possible horizontally oriented branches of a hyperbola. But we're going to stop it at endpoints, and we'll talk about that in just a second. Yes, I'm going to cheat and use my smartboard skills. Well, with my smartboard, I can't do fun shading and whatnot. So at least I can make it look pretty. Symmetric. Maybe not so much. That works. Try to get two as identical as possible hyperbola branches, but do not put arrows on the ends. End them at endpoints. Make them a little bit smaller so it's a little easier for me to draw. Oops. Too much fun. Okay. Oops. Well, it's saving. That's fun. There we go. I apologize. I know it's cold. Let me go check as you guys write. It's cold. It's cold. To play football? Trying so hard. Keep working at it. I mean, he does smile. He has a nice smile. Yeah. Coach Johnson. Torrance? All right. Hey, guys, I want you to be thinking for the first one, where's my rotation arrow going to be? For the first one. Two sheet, formed when revolving around the transverse. Oh! Through! Right? You go across, you go through. So which one goes across these hyperbolas? The y? The x. Good. That was not very centered. That's better. Okay. How about this one? The conjugate axis. If that's the transverse axis, which one's my conjugate? Good. Some of you can visualize these spinning and can visualize what it would look like. Some of you can't so much. Those of you that can visualize, imagine you have these little hyperbolas on a string or on a stick and you start spinning really fast. What's it look like?
Looks like miniature paraboloids. Like a generator.
Miniature paraboloids? Two different ones? Two bowls.
A generator.
Two bowls. Two bowls. Two paraboloids. If you wanted to, you could do your two little coming out in the z-axis. You could have some fun with it, like the paraboloids. Guess those both should have been dotted, but that's okay. 2 bowls. What's the name of these ones? 2 sheet. Think 2 sheets of material. That's kind of an awkward way of thinking about it, but 2 sheets in the sense of they'd be 2 totally separate solids or figures that would need to be formed from 2 totally separate pieces of material. 2 sheets. Now, how is this 2-sheet hyperboloid different than this 1-sheet hyperboloid? Can you visualize? If this comes around, what's he going to run into? Oh, and that one's going to run into. So they're like kind of coinciding, like going together? Huh. Hourglass, I like it.
Oh, it's the hourglass. Please, don't attack me like that. Not right now when I only have 2 functional brain cells.
Only 2. Shh, be nice. You can think hourglass. You can think tornado. Just don't make it thinner at the bottom. That'd be awkward. Poor little hyperbola. Wait, why is that one called a 1-sheet when the other one is called a 2-sheet? It's connected. It's one figure. 1 sheet versus 2 sheet. Red sheet versus blue sheet. Any Dr. Seuss people? 1 fish, 2 fish, red fish, blue fish? Is it blue fish, red fish? Anyway. Okay. Ah! Okay. Do we almost have the hyperboloids, the 2 sheet versus the 1 sheet?
Yes.
The transverse goes through versus the conjugate, the perpendicular one that doesn't hit either branch. Okay. So how is homework going to be different than just like, oh, spin, 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 spin? Okay. Okay, this is very similar to the worksheet. I think it's actually one of the problems from the worksheet. It says, go ahead and make me the paraboloid formed by revolving the part of the graph of 9 minus x. Oh, we have a particular equation, guys. How are we going to graph 9 minus x squared? Ugh. Go back to section 10.2 and then move it and say it's x minus 0 squared equals 1 times y. Ugh. 9 minus y. And then we have to do x minus 0 squared equals negative 1 times y minus 9. And then we have to make this equal to 4p. And then we need to go ahead and find p. Wait, pause. To spin it, do we need the directrix and the focus?
No.
Oh. So do we need the super snazzy, like, yellow box 10.2 formula? Oh. So wait. Where's this guy centered? Can you tell? 9 up from the origin with a downwards facing parabola. Do you remember the old school? You can go up 9 and flip it?
Yes.
Now, could you have done it this way and also seen that, oh, it's going to be x minus 0 squared when I add this to the other side? And then could you have figured out it was negative 1 y? Yeah, maybe it would have helped some of you to actually get it written like that, but you are going to end up just with, oh, go up 9 and flip it. So up 1, 2, 3, 4, 5, 6, 7, 8, 9 and flip it. Flip it. Ooh. Can anybody figure out it's going to hit at negative 3 and positive 3? How did I figure that one out? Couldn't I find the zeros?
Yes.
So the x-intercept is going to be when y equals 0. So I would have ended up with 9 is equal to x squared. X is equal to plus or minus 3. Wait a minute. It says to only steal the part that's in the first quadrant. Well, who's in the first quadrant? I can't go any farther? No. Why do they do this? Why do they have me cut it off? Well, if we're supposed to spin it, how do you spin an infinite figure? I mean, you can, but how do you stop it and make it look pretty? So they have us just to do part of it. Does that make sense? So that we can spin it? Now, wait, why didn't they have us go over here? I'm spinning it around. Do you guys put your rotation arrow yet around the y-axis? What's going to happen when you spin this guy? Where's he going to connect? Oh, so when I spin it, does that mean I can go ahead and draw that after all? If I spin, it's going to go hit that side. Oh, cool. So I can go ahead and draw that side also. And there we go. If you want, you can make your little like, hey, let's make it all nice and spin, 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 spin. Anyway, done. It does look like a bell, huh? Guys are so random. How do we do?
We did great.
Do you see how the first quadrant, how it spun around so we could draw the second quadrant one too?
Yes.
But no arrows going on forever, or else how do you... It's confusing. Okay, so what was different? They gave us a particular equation. They wanted us to spin a particular paraboloid. Okay, cool. Paraboloid. Done. Why y-axis? Because it was the axis of symmetry. What about this one? Hold on. Hey guys, are we able to make hyperboloids as fast as that up 9 down parabola? No. Okay. So what section was hyperbolas? 10-1 lines, 10-2 parabolas, 10-3 ellipses, 10-4? 10-4 hyperbolas. Now, hold on. What's the standard form of a hyperbola? The negative one or the positive one goes first? Good. So y squared minus x squared equals 9. Don't I need division and a 1? Oh, how do I divide and get a 1? Oh, nice. So could I have y minus 0 squared all over 3 squared, right? If I need to write it like that? Minus x minus 0. Haha, there's my hyperbola. Where's he centered? 0, 0. Where do I go for my vertices? Do I go horizontally apart or vertically apart? Why vertically? Y is first. So I'm going to go up, 1, 2, 3. I'm going to go down, 1, 2, 3. Got my vertices. Okay. Do you think I need foci for these? Okay, good. So we don't have to do the whole thingamabob. No foci. But I need my shape. How do I get my branches? Nick, remember, can't hit for my branches. Asymptotes. Asymptotes. Joel, hang in there. We're almost done. Asymptotes. I need to do rise over run. Didn't we already rise 3? How many am I going to run? Run, Forrest. Run. Rise 3, run 3. Rise 3, run 3 the other direction. Now wait a minute. How much of this hyperbola am I supposed to graph? The infinite thing with lots of arrows? No. Why did it tell me negative 6 is 6? That way I know when to stop. So I stop at 6. Sorry, negative 6. I stop at 6. But I also have the branch down here, right? Stop at 6. Sorry, that's negative 6. Stop at 6. Where am I supposed to be rotating? Now, y-axis in this shape, is that the transverse or is that the conjugate? Transverse goes through it, right? Transverse goes across the branches, through the branches. Will hit the hyperbolas. So what is it going to be, a 2-sheet or a 1-sheet? Nice. You see it? Kiddos, we got it. What are you going to do tonight? Everything but 11 and 13, skip it entirely. It's not going to be due at all. You're getting the basic shape and then spinning it and attaching a name. If you finish early, start on the review. Bye, guys. Work on those yellow boxes. We're going to need them.
Okay.